I lost my friend in this box. His name's Particle. Can you help me find him? Schrodinger's equation tells us all we need to know about a quantum system. But what is a quantum system? A quantum system is any area containing particles. Like this. Even our box has a quantum system.
Think of Schrodinger's equation as the F equals ma of the quantum world. If you throw a ball and solve for F equals ma, you can predict the ball's momentum and position for any moment in time. But when we go down to particle land, these equations don't work. If we put a particle in a box and we want to know where it is located within the box, F equals ma doesn't cut it. The Heisenberg uncertainty principle tells us that we cannot know the exact position or momentum of a particle, but we can know other things like its energy and its wave function.
This is a wave function sign. The wave function is something you solve for in Schrodinger's equation to predict the particle's location.
This is a standard wave function, but this does not show the path the particle takes. The x-axis shows where it can be within the space.
But what does the y value do?
Well, if you square the y value of the wave, you get a probability amplitude, which gives you the most likely area for the particle to show up within the wave function.
But the particle will be in a superposition, which means it will be in all probable areas at once, but as soon as we look, it will be forced to choose one.
The other thing we are solving for is E, which is the energy the electron is allowed to have. So if we do all of this, we will get it.
The reason a particle can't have an infinite amount of energy is because of Einstein's discovery that energy is proportional to frequency. Since frequency describes a wave function, this means energy is confined to a space just like a wave function.
Overall energy is equal to kinetic and potential. In some cases, V stands for potential energy. Therefore, this part is equivalent to kinetic energy.
So we find out the potential and kinetic energy. That's all we need in order to find out what the wave function is and what the energy levels are.
So what can we do with this equation?
In 1935, Schrodinger put a cat in a bunker with gas that would kill it 50% of the time.
But while the cat is in the bunker, it is in a superposition of dead and alive. It's just like our particle, which has the ability to be at all places it could be at once.
Schrodinger used this equation to determine whether the cat was dead or alive. But nobody knows how the output was decided. Some say that while one option happens here on Earth, another option happens in an alternate universe. Maybe in some alternate universes I even win this challenge. Maybe with the advancement of quantum science and technology, we might be able to find out what decides this output.